together. But before we do that, let's go ahead and review the distributive property really quick. So let's say you had b plus c inside the parentheses here, and then a outside. So you distribute the a into the parentheses, right? I have a plus case and a minus case. We'll look at that. So I just like to do this myself, just to show myself what I'm distributing the a into. So if this, and again, if there's no symbol in between the parentheses and the a, we know that that's implying multiplication, right? When we see no symbol in between. So right here, this a is going to get multiplied with the b, with a positive b, because there's no symbol in front of it to give us ab. And then once you distribute the a into the c, you got to consider the sign in front of it, right? Which is a positive, so that would be a positive ac. And that would be it for that, right? So that was the positive case. Let's go ahead and look at the negative case. I'm sure you guys have seen this stuff, but I just want to review it before we get into the polynomial multiplication. So in this case, same thing's going to happen. When the a gets multiplied with the b, we're going to get ab. And then now just, you got to consider the minus, right? So the a is going to get multiplied with a negative c now. So now it's going to be a negative ac. Okay? Just wanted to show you guys that really quick before we get into the polynomial multiplication. It's really not hard, it just gets confusing because you got exponent laws and adding polynomials and stuff. So you just really want to get your rules down. Okay, so still doing some more distributive property examples. These are a little bit more complicated, but they're still pretty straightforward. So the 2 is what's going to get distributed into this parenthesis here, right? So I'm first going to take this 2 and distribute it into the 3x. Then I'm going to distribute it into the 4. Okay, so there's no variables here to consider. We'll worry about that in the next example. It's just a number, a constant getting multiplied into the parenthesis. So 2 times 3 would be 6, and we just carry along that x. And then the 2 is going to get multiplied with a positive 4, so that would be a positive 8. And that would be it for that one. Okay, so now let's look at the variable case. So now we have a negative x getting distributed into 3x, and then we have the negative x getting distributed into the negative 6. And just beware of this negative. So let's see. You have a negative times a positive here, so I know I'm going to have a negative anyways, right? And then there's a 1 in front of here, so 1 times 3 would be 3, but you don't, that's just for me to point out, you don't have to write that. And there's also a 1 exponent on the x, right? But that's just me mentioning that, you don't have to write it. So there's the negative, the 3 would come about, because it's pretty much like 3 times 1. X times x, when you have the same base, you add exponents. So 1x and another x would give me x squared. And then finally a negative x times a negative 6. 2 negatives make a positive, oh, I said x for some reason. It's just negative x times a negative 6. Sorry about that. So 2 negatives make a positive anyways. And then negative, and then x times 6, they would just stick together, which would be 6x. So I just wanted to give you guys some more examples with the distributive property. Okay, so why don't you guys go ahead and give this a shot, and then when you come back, pause the video or whatnot, and when you come back, I'll go over it with you. So assuming you gave that a shot, what's going to get distributed into the parentheses here is the 5. So I'm going to distribute the 5 into the 3x squared first, and then into the 4. And I'm not going to write the equal sign here. I don't know why I did that. So there's no variable to consider here, so it's just the 5 is going to get multiplied with the 3, which would give us a 15. And then the x squared, we're just going to carry on. And then 5 times a positive 4 would be a positive 20. So that would be it for this one. Okay, so still going along with the distributive property. Now notice inside the parentheses there's more than 2 terms. So it's really not different than the other cases. We're just going to distribute the negative 7 into every single term we see inside the parentheses. So this negative 7, I'm going to distribute it into this 2x squared. Then I'm going to distribute it into this negative 4x. And then I'm going to distribute it into the 6. If there was like a million terms there, I would just multiply it into every single term. It's really not different than what we've been doing. So again, there's no variable here, so I'm just multiplying a constant into each of those terms. So negative 7 times 2 would be negative 14, and then I'm going to carry along that x squared. Negative times a negative would be positive. 7 times 4 is 28. And again, that x is just going to carry, we're just going to carry it along. Negative times a positive would be negative, and then 6 times 7 is 42. Okay, so why don't you guys go ahead and try this example where you distribute something into the parentheses that has more than 2 terms, and then I'll go over it with you guys. Okay, so assuming you gave that a shot, in the previous example that I did, we just had a number or a constant to worry about. Now we have a constant and a variable. So I'm going to take this 4x cubed and distribute it into the x to the 4th power, and then distribute it to the 9x squared, and then finally distribute it into the negative 8. So when we do that, I hate to be annoying, but there's a 1 in front of here. So 1 times 4 is 4. Then worrying about the variables, when you multiply variables together, you add their exponents. So 3 plus 4 is 7. Moving on, we have a positive here. So 4 times 9 is 36. Now with the variables, again, they're the same. So we're going to add the exponents. 3 plus 2 is 5. And finally, this guy doesn't have a variable. So it's just the constants or the numbers that we take into consideration. So positive times a negative is a negative. 8 times 4 is 32. And then that x cubed is just going to we're just going to carry it along. So this should be your answer if you tried it by yourself. Okay, so now that we reviewed the distributive property, let's move on to multiplying some polynomials together. But first, let's multiply some binomials together. And the way we're going to do that is by the FOIL method. So the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So what does this really mean? When we're talking about the first, we're talking about the first term in this parenthesis getting multiplied with this guy right here. That's what the first indicates. When we're talking about the outer, we're talking about this first guy, first term in this parenthesis getting multiplied with this outer guy here. That's what the outer means. And then once you move on to the inner, since I already distributed the x into both of these terms, I have to move on to the 4. Because now I have to distribute that. So the inner is indicating this part right here, the 4 getting multiplied with the x. And then the last is indicating that you're multiplying this 4 into the last term here. So I don't know if I really explained that the best, but we're going to do some more examples to get the feel for it. But really you could think about it like the distributive property, because if this 4 wasn't here, you would just take that x and distribute it into each term in the parenthesis, right? And then if this x wasn't here, you'd distribute the 4 into each of those terms there. So you could think about it as the distributive property, which is really what we're doing. So let's see what this would look like. So the x times the x would give us the x squared. That's coming from the first. Moving on to the outer, it's the x times the 2. Which would give us the 2x. Now we're moving on to the inner, which is the product of these two. So that would be 4x. And then finally the last would be these guys getting multiplied, the 4 and the 2. So that would give us an 8. And then there's a little bit of combining like terms there. So then you get x squared plus 6x plus 8. So that's how you would go about multiplying these two binomials together. You'd have to use the FOIL method to do it. So let's go ahead and do some more examples. Okay, so I briefly showed you guys how to do the FOIL method. So why don't you guys go ahead and attempt this one. And then if you can't do it all the way, it's fine. I just want to see you guys attempt it, and then I will go over it with you. So assuming you gave that a shot, going off what FOIL is telling us to do, we're going to take this first term here and multiply it with the first term here. Then the outer, we're going to take that same term and multiply it with the outer guy here. Moving on to the inner. Since we already distributed the 3x into each of those terms, we have to move on to the 2, right? So the inner is the 2 getting multiplied to the x. And then the last part is where you take the 2 and you multiply it by this last guy here. Again, it's just like a distributive property, right? If this guy was in here, you distribute that into both. And if this guy was in here, you distribute the 2 into both. So it's really like keeping the distributive property in the back of your mind helps out a lot. So let's see, 3x times an x would give us a 3x squared. 3x times the 1 would give us a 3x. So I've distributed that 3x into everything. I want to move on to the 2. 2 times x would be a 2x. And then 2 times the 1 would just be a plus 2. And then notice you could combine these like terms here. So we get 3x squared plus 5x. 3x plus 2x would be 5x. And then plus 2. So hopefully you got the same answer as me. Okay, so here's the last FOIL example. Go ahead and attempt it. And it might look intimidating, but if you just stick to the FOIL, you should be good. Alright, so assuming you gave that a shot, just going off what FOIL says, so taking the first, multiplying with the first here, taking the, going off the outer now, so I'm going to take this first term and multiply it with this outer guy here. Moving on to the inner. Since I already distributed this guy into everything, I move on to the 3. There's the inter, and then here is the last. Okay, so let's see what that gives us. A negative times a positive would be a negative. The 4 is getting multiplied to a 1 here, right? And then x to the first power, x to the second power, that would give us an x cubed. So now negative 4x times a negative 2x. Negative times a negative is a positive. 4 times 2 is 8. And then x times x would be x squared. Now I'm done distributing this guy. I'm going to move on to the 3. So 3 times an x squared would give me a 3x squared. And then 3 times a negative 2x would give me a negative 6x. And then again, notice I could combine these guys here. So you get negative 4x cubed. 8x squared plus 3x squared would give you 11x squared minus 6x. So again, I would just suggest be careful on the computation part, because I don't think the FOIL is that bad. It's just I think the problem could go wrong in the computation, so you just want to maybe be